Hello, in this video I'm going to be showing you how to get the simple time dilation formula, which is change in time is equal to gamma times change in time prime. Now to get this equation you need to know two things. That is, with Einstein's special theory of relativity there are two assumptions. Number one, the speed of light is the same for all observers, regardless of how fast they are moving. And number two, the laws of physics are the same for all observers, no matter how fast they move. In terms of equations, you need to know that speed is distance over time. This means that speed times time is equal to distance, or velocity times time is equal to distance. What's also required in terms of equations is Pythagoras Theorem. That is the simple a squared plus b squared is equal to c squared. I've left the link below this video where you can see the proof for Pythagoras Theorem. If you don't understand why a squared plus b squared is equal to c squared, then I would recommend watching it. So moving on to the time dilation formula. What there is going to be is a moving cell, and a light pulse is going to travel from the bottom of this cell to the top of this cell, okay? There will be one observer inside the cell, which is called T prime, and one observer outside the cell, which is called T. Now, for the observer inside the cell, she is unaware that it is moving, and she will see a light pulse travel because speed times time is equal to distance, c times change in t prime. Now, for the observer outside, he's going to see the same light pulse travel from the bottom to the top of the cell, okay? But that light is going to be moving diagonally from his perspective. So he is aware that the cell is moving, and from his perspective, because speed times time is equal to distance, he will see light traveling at c times change in t, okay? So this is what observer T prime sees. Light travels c times change in t prime, and this is what observer T sees. Light travels c times change in t, okay? Now, because this cell is moving, right, what we have for this distance over here, okay, is v times change in t, which is the same as velocity times time is equal to distance, okay? So this is the actual distance the cell has traveled, and this is what, this over here, the hypotenuse, is what observer T has seen. Now, with this right-angled triangle that has been formed, we can get the equation for time dilation. Now, considering both viewpoints, one for observer inside moving cell and one for observer outside moving cell, plus Pythagoras' theorem, we can write that v times change in t squared plus c times change in t prime squared is equal to c times change in t squared. This equation over here comes about by looking at this diagram over here and using Pythagoras' theorem. So that is adjacent squared plus opposite squared is equal to hypotenuse squared. So if you manipulate this equation over here and take these steps, all right, what you can find is that change in t is equal to gamma times change in t prime. This over here is called the Lorentz Factor, okay? And it's part of the time dilation equation. Now, if you want all the workings, just visit mathematics.proofs on Instagram and click on this link over here and you'll get all of it free. If you have any questions or feedback related to this video, then leave your comments below and I'll try to respond. Together with this video that you've just watched, I would recommend watching episode 42, the Lorentz transformation, the mechanical universe, which can be found on YouTube. I've left a link to this video below this one, so you can watch it if you need an extra perspective about this time dilation equation. Thanks for watching this video, and I'll see you next time.